Okay, so we're going to look at vertex form of a quadratic. So this is your vertex form right here, and the reason why it's called vertex form is because you can automatically look at an equation in vertex form and automatically find your vertex. So notice in vertex form you have A, H, and K, all right, which all represents your transformation rules for like any function that we've been working with. So like this A is going to be your vertical stretch or shrink, right? This H is going to be your horizontal shift, so like left or right, and the K would move it up and down, right? So the vertex can easily be found. Remember, x's are crazy, so if you had like x minus 5 here, right, you would know it'd go right 5, so then it would be a positive 5 as the x-coordinate of your vertex. So you would flip that sign to give the x-coordinate of your vertex, and then whatever the k value is here, remember what you see is what you get, so that k value is your vertex. So you can automatically look at this and know where your vertex of your quadratic is. So here's your quadratic, parent function, very rough sketch, y equals x squared is the parent function equation. So notice the difference here. Nothing's been added or subtracted or multiplied to it. So this is the most basic form. This is your parent function. So anything added, subtracted, multiplied would be considered a transformation. All right, so your vertex on your parent function is at 0, 0, but I'm just going to still label that as hk. In this case would be 0, 0 for the parent function. And then we have this vocabulary word, hopefully you remember, it's called axis of symmetry. And remember, that's the line that divides your parabola, this is your parabola, into two equal halves. So it just so happens on the parent function, it just happens to be your y-axis right here, but that's called your axis of symmetry. It's the line that cuts your parabola into two equal halves, and you can write that definition out if you need to. You can pause it and write that. The line that splits your parabola into two equal halves. All right, but the axis of symmetry you can also get by just looking at your equation. All right, and so notice your axis of symmetry, as long as your parabola is either facing upwards or downwards, okay, then it's always going to be a vertical line, and it'll be x equals whatever the x-coordinate of your vertex point is. So x equals h is how we can write that generic statement. And again, that's for if the parabola opens up or down, which is what we're going to kind of just focus on today. Okay, that's kind of generic overview. So let's look at example 1 here. All right, so we have y equals 3 times x minus 2 squared. I'll kind of put that away. Minus 4. So let's first get our vertex. So remember, it's h comma k, but remember the h, it's x minus 2, but we flip the sign. So the vertex is going to be positive 2, and then the k value is right here, so minus 4. So that's your vertex. Let's do our transformation. So right here, it's a number bigger than 1, right? And so whenever that number is being multiplied to your function and it's greater than 1, that's a vertical stretch by that factor. So vertical stretch by 3. Okay, and then again, to kind of get our vertex point, we know x's are crazy, so this actually shifts to the right 2. And then the minus 4 on the outside, what you see is what you get, down 4. So those are your transformations. Okay, so before we're going to graph, we could go ahead and plot our vertex point. So we can plot 2, negative 4. So 2, negative 1, 2, 3, 4. And I'll just put a little v there for vertex, just to remind myself, or you could write it out. Okay, so unlike absolute value, if you can think back to absolute value, remember absolute value, this number was your slope. Okay, that's a little different because on the parent function, it's not a constant slope. It doesn't always go up 1 over 1, up 1 over 1, or up 2 over 2, that kind of thing, okay, because we're squaring it. Okay. So instead of using slope, we have to pick a point to plug into this equation to plot. Okay, and then I'll show you how you can still create a rough sketch without having to create a super long t-chart. We'll just use one point to get another point, and then be able to get the rough sketch of the graph. Okay, so pick a point, doesn't matter, you pick any x value. any x value. Okay, I would suggest doing 0, just because 0 is pretty easy to do mentally, but it doesn't matter. Okay, so if we were to do 0 something, okay, you're going to plug in 0 for x and then simplify. So kind of the math here, to solve for the y coordinate, you would do 0 minus 2 squared minus 4. Okay, so hopefully you can see how it's pretty easy to do in your head from here, right? So 0 minus 2 is negative 2. Negative 2 squared, so negative 2 times itself, negative 2 times negative 2 is positive 4. So y equals 3 times positive 4 minus 4. So 3 times 4 is 12. Again, I'm just writing it out to show you kind of what you could do mentally. Therefore, y equals 8. So your pick a point, you're not just picking a random point, you're kind of picking a random x value to substitute in, okay? But then you're going to plug in and solve for y. So my random pick a point is 0, 8, but it's not random, it actually falls on this equation. So make sure you plug it in, whatever x value you choose, into this. If I'm asking you to make a rough sketch, be wise. Like if you pick 100, I mean, you technically could do that, right? And I guess you could just do a super rough sketch, but like be smart and reasonable within, if I have you graph. If I just want a random point, it doesn't matter. Okay, so my pick a point is at 0, 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, so that's my like random point. Okay, so I know my parabola, look how steep that is, which makes sense because it's a vertical stretch. All right. Alright, so instead of having to pick another random point to get that full parabola, this is where our axis of symmetry can come in handy. Alright, so remember your axis of symmetry goes through the vertex point and it cuts your parabola into 2 equal halves. So at this point, we can count how far away it is from our axis of symmetry. We can mirror image it to the other side, creating that full U-shaped graph. Okay, so from this point, notice it's 1, 2 units away, and I can kind of draw that if you want me to. So 1, 2 units away from the axis of symmetry. So on the other side, like if you were to fold your paper over, and this marker could bleed to that side, right? It would plot a perfect point on the other side. So from here, we have to go 1, 2 units over and plot a point. Really right there. And we know that this is the point of reflection. And so now we're able to complete that full parabola. Okay, so again, you just pick a point, and you count how far away it is from your axis of symmetry and reflect it on the other side to get that good sketch of the graph. Okay, your domain for any quadratic is going to be all real numbers, or from negative infinity to positive infinity, as long as it's not finite, meaning if it had endpoints, it would be different, but as long as it extends to forever to the left, forever to the right, your domain is negative infinity to positive infinity. Okay, but let's write our range. So our range is the lowest point to the highest point. So lowest point is negative 1, 2, 3, 4. So negative 4 gets a bracket for interval notation, because it's a plotted point, and then the highest point is infinity. It will increase forever. Okay, so that's kind of how we can use the vertex form to do a rough sketch of the quadratic graph. Okay, so let's look at another one. So example 2. Okay, and if you want to go ahead and pause it and see if you can do this by yourself and then kind of fast forward in the video a little bit to where I put the answers, go for it. Okay, see if you can't get this one by yourself, if you already feel like you have a pretty good hang of it. Okay, but if not, I'll still walk you through it. So vertex point, remember, look in with the x, flip the sign because x's are crazy. So negative 1. Number on the outside, what you see is what you get, so positive 3. It's your vertex. Okay, so our transformations, and you can write your transformations first, and that will help you get your vertex point, okay? So transformations, remember this negative right here is its own transformation. So that negative, remember, is a reflection over the x-axis. So this parabola, instead of facing upward, is now going to be facing downward. All right, the 2 is its own thing, and that's a vertical stretch by 2. Let's see if I can squeeze that in there. Vertical stretch by 2. This plus 1 is a transformation, and remember x's are crazy, so that's going to translate left 1. And then the final one is up 3. All right, so let's pick a point to do our graph. So we can go and plot our vertex point. So the vertex point is at -1, 3. So 1, 2, 3. That's my vertex. Just so I can remember. Okay, so then my pick a point, again, it may be that you don't have to, but I just like to put 0 in just because it's pretty easy mental math, but you don't have to. Okay, so you are going to sub that in to your equation. So -2, 0 plus 1 squared plus 3. So 0 plus 1 is 1. 1 squared is 1. So you'll have -2 times 1 plus 3. So -2 times 1 is -2. -2 plus 3 is +1. So my y value over here is 1. Okay, so my random pick a point, I can plot at 0, 1. Notice it's going, whenever I go from my vertex to my random point, it's going to create that parabola that's going downwards, which is what I want, because remember that transformation is a reflection over the x-axis. So now it'll be flipping down automatically. Okay, then we use our axis of symmetry. We can draw it through our parabola, so it should go through -1. And then we can count how far away this point is from our axis of symmetry. So notice this one is only 1 unit away from the axis of symmetry, so that means on the other side, I plot 1 unit away to make that parabola. Okay, so again, domain should be all real numbers because it extends to forever to the left, forever to the right, but I'll practice writing the range for you. Okay, so this one I'll do in set notation, so all the y values such that, and you could write this in a couple ways. You could say all the y values less than, what value is that? 1, 2, 3. Okay, because the highest value is 3, so all the y's less than or equal to +3. Or if you wanted to write it as a compound inequality, all the y values such that -infinity, so you always go lowest to highest, is less than y, which is less than or equal to +3. Okay, so that's how you could represent the range in set notation for that quadratic.